So last section, 8.6. Law of cosines. So we're going to start with the same kind of triangle that we started with for law of sines. So just our generic triangle. And we'll label it like we did before. So just kind of a reminder of how we label these triangles for law of sines, law of cosines. Capital letters for the angles, and then small letters across from the angles for the sides. So there's our triangle. And just like for law of sines, we're going to say we don't have to have a right triangle to use law of cosines for any triangle ABC. Now what I'm going to do is write, usually law of cosines we write three different equations, kind of like with law of sines we ended up with three different equations. But with law of cosines it's really just one equation. The different equations just come from how we could label our vertices differently. So I'm going to say a squared equals b squared plus c squared. So what does that, that's not all of it, but we'll write some more. But what does that kind of look like? It kind of looks like the Pythagorean theorem. Law of cosines is related to the Pythagorean theorem. Now I'm going to say minus 2bc cosine A. So it's like the Pythagorean theorem, but we have this little extra bit at the end. And that's what makes up for the triangle not being a right triangle. Yes. Yeah, this works for any triangle. And then now I'm just going to write different versions of this same equation, and really they have to do with how you label the vertices. So we could say b squared equals a squared plus c squared minus 2ac cosine b. And the last one, I'm going to move this capital C here. We get c squared equals a squared plus b squared minus 2ab cosine c. So I want to point out a couple of things about the law of cosines. It's a little, the equation is a little more involved than law of sines. The law of cosines takes a little more work to do than law of sines. Not quite as nice, not quite as compact. But if I have a squared on this side, on the left, I have angle A on the other side. If I have b squared on this side, I have angle B on the other side. If I have c squared on this side, I have angle C on the other side. So the side that we're looking for and the angle that's across from it are on opposite sides of the equation. If I have a squared on this side, the other sides on the right side of the equation are always b and c. There's a b squared, c squared, and a bc there. So this is the only place that side A shows up. These are all b's and c's. Here we have b squared. Now we have a's and c's. Here we have c squared, and these are all a's and b's. So the side and the angle are on the opposite sides, and then whatever's here is different, the different sides from what's there. And I think what I'll do for the test is I'll probably just write one of these up on the board. Like that first one, write it just so we remember what it is. All right. Now, we said this kind of looks like the Pythagorean theorem. It turns out that if C, for example, was a right angle, 90 degrees, the cosine of 90 degrees is 0. So this whole thing turns to 0, and we get c squared equals a squared plus b squared, the Pythagorean theorem. So the law of cosines and the Pythagorean theorem are really the same thing. And the law of cosines becomes a Pythagorean theorem if we have a right triangle. So it's nice when things in math work out that way. All right, so we're going to use law of cosines. So we had a couple different kinds of triangles that we said we use the law of sines for. We use the law of cosines for side angle side triangles. So we have two sides and an angle between. Or we use it for side, side, side triangles. And when we have a side, side, side triangle, we use it to find an angle. So between the law of sines and the law of cosines, we can use some formula to figure out things about our triangles for any kind of triangle that we have. All right, so what I want to do is just go through an example of using law of cosines for a side angle side triangle and for a side 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 triangle. And we'll go through as I go through the examples, I'll point out where students sometimes make mistakes with law of cosines. All right, questions? We good? Okay, let's look at a couple of examples. And while we do this, I'm going to start up this calculator. There's the one I want to start up. So here's my triangle. And I'll call this triangle A, B, got pretty close there, C. And I'll say angle A is 50 degrees. This is side A. Side B is 14. And side C is 8. And we want to find A. Now, here we have a side angle side triangle. So we use law of cosines. If you tried to use law of sines here, I'd make a ratio with this angle on this side, and I want to make a ratio with this angle on this side, or this, but we're missing too much stuff. We're missing, if we tried to set up law of sines, for these two, I'm missing that. For these two, I'm missing that, and for these two, I'm missing that. So I wouldn't have enough stuff to put in the law of sines. So that would be a clue that you can't use law of sines. So we're going to use law of cosines. And since we're finding side A, I'm going to use A squared equals B squared plus C squared minus 2BC cosine A. And we're going to find A. Mm-hmm.
So whichever one you're finding goes in like the beginning and also
Yeah,
the end.
that's, yeah, the beginning and the end. That's a good way to think of it. And now I'm going to plug in numbers. So when you do this, you don't necessarily have to go through every single step that I go through in this example. I just want to go through the steps to show how we plug the numbers in, and then also to point out some things that you can't do when you do law of sines. Some things that I see students do that you can't do in math. So A squared equals B squared, 14 squared, C squared is 8 squared minus 2 times 14 times 8 times the cosine of 50. Now, if you have a calculator, the most common kind of calculator, these Texas Instruments calculators, from here you can plug this straight in. And I'll do that in just a second. But, and with the other, when we do the other side, side, side triangle, there's a little more work. So I'm going to calculate things out a little more, just because sometimes students do that, and I want to make sure you don't make mistakes when you do that. 14 squared is 196. 8 squared is 64. Minus 2 times 14 times 8 is 224. And the cosine of 50 is 0.6428. So notice if I do it this way, I keep that 4 decimal places.
So for the 2 and the 14 and the 8, you just did 2 times 14 times 8.
2 times 14 times 8.
And then you did 224, and then you did the cosine of 50.
Cosine of 50 is 0.6428. Now I'm going to do one more step before I do anything with this. 196 plus 64 is 260. Now, one place that students make mistakes is they say, oh, this is 260 minus 224. You can't subtract here because this 224 is with this 0.6428. So it might be a good idea to put parentheses there in front of that minus. So you remember that all this stuff with the cosine has to stay together. You can't just take part of it away. Now I'm going to multiply these together. 260 minus 224 times 0.6428 is 143.984. Now that I've multiplied these two together, I can subtract. So this is a squared. A squared equals 116.016. The other thing to remember here is that this is a squared. So we have to take the square root to finish. So we're not getting a here, we're getting a squared. So to finish, I take the square root of both sides, and a equals 116.016. Oh, sorry. I wrote it the same number twice. Got to take the square root, 10.8. Now, yes.
Like on a test, would you specify like how many
Yeah, I'd say round to the 10th or some round to the whole number. I rounded this one to the 10th. All right, so that's a step-by-step method. Let me go back to here, and I'm just going to show you how to plug that into your calculator all at once. For this type of problem, you can, if you have this type of calculator. For these, when you have, usually with law of sines and law of cosines, it won't be in simple radical form because you'll have decimals, almost always. All right, so I'm going to do 14 squared plus 8 squared minus 2 times 14 times 8 times the cosine of 50. So I typed it in just like we wrote it down. I hit enter, and I get that 116.016. So that's our a squared value. And then we could take the square root. To take the square root on these types of calculators, you can do second, the square root is right here. Second square root, and then I'm going to do second answer. And there's my 10.77 that I rounded to 10.8. So your square root is usually a shifted button by your x squared button. And on your Texas Instruments calculators, the answer button is the shifted button from this minus. Here. All right, questions on that one? So in our activity, we'll do some law of cosines problems that are like this example. All right, let's look at a side-side-side triangle, because there's a little more to side-side-side triangles. Oops, that's not what I wanted. I want this. Oh, did the same thing. I want this. There we go. So I'm going to call this P, Q, and R. Thank you. What I don't, there, that's an R. Still two Q's. That's a P. Alphabet messes me up in math class. All right, and I'm going to say side Q is 1.25. Side R is 3, and side P is 2.5. And for this one, we want to find all the angles. 2.5. Now, if you don't like the way that the triangles are labeled, relabel them the way you want them to be labeled. If you want, you could call this A, B, and C, and this would be A, B, and C. You can relabel the triangle however you want so that it works, so that it matches up with how you like to use the formula. My personal preference, I think of the law of cosines, I always think of this first one. So I always think of it that way. I don't ever think, this is just the way I think of it. So I like to label my triangle so that I can always set it up this way. So you can always do that. We want to find all the angles. Well, we have a side-side-side triangle. We have 3 sides. So that tells us use law of cosines. And you'll learn why. Your pre-calc teacher should teach you why. But when you find angles, we're not going to worry about why right now. When you find angles, find the biggest angle first. So what angle is going to be the biggest? A is going to be the biggest because it's across from the longest side. So let's find angle A. So I know that when I set up my law of cosines problem, I'm going to have on this side cosine A. And we know that whatever angle is here, so we're going to find that angle. The other side, the side across from that, has to be on the other side of our equation. So that's going to be 3 squared. That's A squared. I'm going to write that there. Equals B squared plus C squared. So we're going to say 2.5 squared. And I'm just going to write that down here. That's B squared. And then we have 1.25 squared. That's C squared. And then we have minus 2 times 2.5. I'm going to move my cosine over. Times 1.25 times the cosine of A. And here, what we're going to do is we're going to solve this equation for cosine A. So we're going to end up with cosine A equals something. And I can continue this as minus 2BC. So this kind of problem takes a little more work. So let's calculate. 3 squared is 9. So we're going to say 9 equals 2.5 squared is 1.5625 plus whoops, sorry, that's 1.25 squared. 1.5625. 2.5 squared is 6.25. So we have 6.25 plus 1.5625 minus 2 times 2, 2 times 2.5 times 1.25 is 6.25. So 6.25 is 2 times 2.5 times 1.25. So here we have to be careful. I can't say, oh, here's 6.25 and here's minus 6.25. I'll just subtract those and those go away. This 6.25 is attached to that cosine A. So if it helps you, put a set of parentheses there. So I get 9 equals 6.25 plus 1.5625 is 7.8125 minus 6.25 cosine A. These two are still attached. I can't do anything with that 6.25 yet. I want to get cosine A by itself. So I'm going to subtract 7.8125 from both sides. So 9 minus 7.8125 is 1.1875. These go away, and I get that equals minus 6.25 cosine A. Now I can do something with that negative 6.25. I want to get cosine A by itself, so what am I going to do? Divide. So we divide both sides by negative 6.25. And these go away, and I get that cosine A equals 1.1875 divided by negative 6.25 is negative 0.19. And now I want to find angle A. So what do I do? No, you just plug this into your calculator. 1.1875 divided by negative 6.25. And that's negative 0.19. Now we have to do the inverse to find the angle. So A is the inverse cosine of negative 0.19. And I'm going to go to my calculator, clear that away. Inverse cosine of negative 0.19. Enter, and I get 100.95. Nope. You square root if you're finding a side. For the angle, you don't have to square root. I'm going to use whole angles here, so I'm going to round up to the whole angle. So I'm going to round that 100.9 to 101. So A, I'm going to say is 101 degrees. So to find an angle takes a little more work. So let's put that over here. So angle A is 101. But here the problem says find all angles. We could use law of cosines again, but we've seen that law of cosines takes quite a bit of work, right?
Just use the law of sine.
Now we can use the law of sines, because we can match this angle, this side that we know, and we could call this, you want to call QX? So we can do that one. Match that angle with that side. So now we can finish with the law of sines. because law of sines is way easier to use. So I'm going to say sine of 101 over 3 equals the sine of x over 1.25. So this looks exactly like our opener now, just with different numbers. Multiply both sides by 1.25. You could cross multiply, that will work also. Those cancel, and I get sine x equals 1.25 sine 101 divided by 3. And what do I have to do here? Inverse. Good. I think we've got that now. So x is the inverse sine of this whole thing. 1.25 sine 101. Whoops. Divided by 3. Plug that in my calculator just like that. And I get that x equals, rounding to the whole number, 24 degrees. No, I have it written down.
Yeah, I did more than expected. Did you do one with the dash disease, or do you want like all the roots?
That wants the roots.
Okay.
So yeah, I had it calculated and written down. That's how I knew. I can't do that mental math. I don't know that. And do we need to do law of sines or law of cosines for the third angle? No. What do we do? Add these two and subtract from 180. So angle P. You might be able to do mental math for that one. P is 180 minus 101. Whoops, 101 minus 24. And that turns out to be 55 degrees. So now we have all the angles, all the sides. So we would say we've solved the triangle. Law of cosines, especially when you're finding an angle, takes a little bit of work. All right, questions? Okay. So we're on page 530, number 8 through 18 even.